Hey everyone, it's Matt here. Welcome back to another episode of Savant's Tech Talk. The world of quantum computing has seen noteworthy discoveries ever since the inception of the electronic calculator back in the 1960s. The last couple of years in information processing have been particularly exceptional. What was once considered a part of science fiction is now a technical reality. Classical computing has become exponentially faster and more proficient, and our enabling devices are more compact and adaptable. We're seeing an era evolving beyond classical computing into a new data-oriented one called quantum computing. It's predicted that quantum computing will drive us into the future by transforming the fields of artificial intelligence and data analytics. The potential and speed of this technology will assist us in solving some of the biggest and most challenging questions we face as humans. According to the research firm Gartner, quantum computing is the use of atomic quantum states to affect computation. Data is held in quantum bits or qubits, which are capable of forming all states simultaneously. Data held in qubits is influenced by data held in other qubits, even when they're physically disconnected. This is known as entanglement, and to put it simply, quantum computers use qubits rather than usual binary traditional bits of ones and zeros for digital communications. In today's video, we'll be looking at the evolution of quantum computing. As always, if you find this topic interesting, then you can let us know by hitting that like button and subscribing to this channel for more videos. You can also let us know if you find it interesting by saying so in the comment section down below. Now let's jump into it. In order to understand it in a better way, it's essential to take a step back and understand what it is exactly that computers do. Let's begin with the current digital technology. At its core, a computer is an arithmetic machine. It's made for doing computations cheaply, and its impact on society has been tremendous. We would have never reached the moon or put satellites in orbit without digital computers. These computers measure binary signals in bits or bytes. The more complex the code is, the more power and time the machine requires to process it. This means that for all of their discoveries, right from autonomous cars to beating chess grandmasters, there are specific tasks that digital computing devices struggle with, even though the task is spread across millions of machines. A specific problem they struggle with is a subset of computation called combinatorics. These calculations consist of finding an arrangement of items that leads to a goal. As the number of items increases, the number of possible arrangements increases as well. To select the best out of the lot, digital computers have to iterate through each permutation to find the optimum result and then determine which does best at reaching the goal. In many cases, this needs a massive amount of calculation. And the challenge associated with combinatorics exists in many fields, including finance and pharmaceuticals. And more importantly, it's a bottleneck in the development of artificial intelligence. And this is where quantum computing comes into the picture. Similar to how traditional computers lowered the cost of arithmetic, quantum computing indicates a similar cost reduction to calculating complex combinatorial problems. And here's the really exciting thing. Quantum computing might be closer than you think. Quantum computers indicate a paradigm shift in the field of computation, and we're entering a revolutionary period in the development of quantum computers. These machines are scaling in terms of both size and reliability. Also, they're close to demonstrating a real advantage over traditional computers. Since quantum computing is still in its early stages, it's most likely that its true potential isn't even completely understood yet, and that there's a lot more to discover. And this makes the field even more interesting to follow. Public and private organizations are considering expanding in the journey for quantum understanding. For example, researchers and scientists from the US Department of Energy built 5 new national quantum information science and research centers. And the national labs in the US will be working together to help catalyze quantum information science research. The organizations that are a part of these research centers include Lockheed Martin, IBM, Applied Materials, Microsoft, and Intel. Besides, these research centers were funded from the $1.2 billion allocated by the National Initiative Act. Now let's have a look at some of the significant benefits and applications of quantum computing. Although they're computational, quantum computers can lower the power consumption from 100 to 1,000 times when they use quantum tunneling. Quantum computers will provide solutions to the most complex challenges at an enormous speed. Researchers and scientists are working to develop algorithms to find solutions to problems related to quantum speedups. This technology is crucial since we're in the big data era, and we need resourceful computers to process vast volumes of data produced every day. The speed of quantum computers will benefit a lot of technologies that need high computational power, such as 5G, machine learning, bullet trains, and a lot of other transportation methods, and so much more. The scientific fields that will be directly benefited by quantum computing include mathematics, algebra, statistics, chemistry, physics, quantum mechanics, and biology. In addition to this, applications for the industry will consist of sectors like space exploration, healthcare and pharmaceuticals, cybersecurity, cryptography, finance, commerce, energy, communications, and so many other industry verticals. In fact, any industry would benefit from quantum computing that considers data as a main ingredient. These breakthroughs and discoveries are still just the tips of the iceberg since there are so many other groundbreaking developments in the field. A significant amount of research, development, and prototyping still needs to be conducted. Numerous scientists and researchers still consider quantum computing to be theoretical. However, some consider the technology to be approaching the transformational quantum gate that will enable us to enter a new computational era. Many tech giants, governments, and academics in the industry are now investing huge amounts of money for research and development purposes. Also, they're contributing to the quest to build functional quantum computing. We're on the road to the new computing era, and even though quantum computing may still be in its early stages, it's closer to us than we've ever imagined. So there we have it, a look at quantum computing. Once again, if you found this video interesting, don't forget to let us know by hitting that like button and subscribing to this channel for more videos. Thank you for watching.